All grade 10.
Okay, so just working on these ones here, guys. Okay, name the type, write the names, balance it, all right, and then we'll move on to some that are word to formula instead. All right, let's have a look at a few of these here. So for question number one, I've got, if we're writing this one out in words, I have iron reacting with hydrogen chloride, okay, an ionic compound as well, to produce iron 2 chloride, right, because this is a -1, and there are 2 of them, which gives me 2 negatives, right, so this is the iron with the 2+ charge, okay, iron 2 chloride, okay, plus hydrogen. All right, what kind of reaction is that? Single replacement reaction. Yep, it's an element reacting with an ionic compound. Okay, I need to balance this thing. Right now, I have 2 chlorines and 2 hydrogens on the product side, but I only have 1 of each of those, and they're together on the reactant side. So what needs to go in front of hydrogen chloride? Right, because by putting that 2 there, that gives me 2 hydrogens and 2 chlorines on the reactant side. Now my chlorines are balanced, my hydrogens are balanced, and there's 1 iron on each side, so the whole reaction is balanced as well. Okay, questions on that first one? Now, if this was a question on, let's say, an assignment or a quiz or something like that, what I usually do is I give 1 mark for the reaction to be written correctly in words. Sometimes I give 1 mark for the reactants and 1 mark for the products, kind of depends. Okay, and then you would get 1 mark for the type and 1 mark for it being balanced correctly. Okay, so that means, guys, that if it was 1 mark for the reaction in words and you forgot the Roman numeral, you don't get the mark for the reaction in words. Okay, it makes sure that you really got to know all that naming stuff. Okay, all right, how many people are done number 2? All right, what kind of reaction are we looking at in number 2? Synthesis, right? We got 2 elements reacting to form a compound. Those elements are sodium and chlorine, and they are reacting to form sodium chloride. Okay, right now the only thing out of balance is chlorine. Okay, there are 2 on this side, and there's how many over here? 1. Okay, so what needs to go here? 2. Okay, that gives me how many sodium? 2. Good now? Yeah. Okay, how many people have done number 3? Okay, what kind of reaction is number 3? Decomp. Okay, and it's water breaking down into hydrogen and oxygen. Okay, so we've seen that one before. Okay, and then if I want to balance it, the hydrogens are already balanced, but there's only how many oxygens on this side? 1, but over here there are 2. So what needs to go in front of this? How many hydrogens does that give me? 4. So what needs to go here? 2. Right. Okay. How many people have done number 4? Okay. So with calcium and oxygen, so we got calcium plus oxygen gives us calcium oxide. Okay, what kind of reaction is that? Synthesis, yep. Okay, and to balance that, the only thing out of balance is oxygen. I need to put a 2 here to balance that, but that also gives me 2 calcium, so I got to put a 2 in front of that. Okay, and let's look at number 5, and then I'm going to put some that are word to formula up here. All right, so this is aluminum. Sorry, guys. Oxygen gives us aluminum oxide. And, okay, so the balancing on that one is maybe a little bit trickier. Okay, so I've got 3 oxygens on the product side, but I only have 2 in the reactants. What's the lowest common multiple? 6. Okay, so what needs to go in front of the aluminum oxide? 2. What needs to go in front of this oxygen? Okay, and what needs to go in front of the aluminum? 2. 4. 2 times 2 is? 4. Yeah? Okay, Now, these ones are not like super tough. In fact, they're probably easier than the ones we did yesterday, but they are word to formula. So I still want the type, I still want the obviously formula reaction, and I want it balanced, please. So on our first one, we've got magnesium and chlorine produce magnesium chloride. So magnesium looks like that. What do I have to remember about chlorine? It's special, yeah. Okay, and it produces magnesium chloride, which is an ionic compound. So thus, with this compound, I need to do what? Drop and swap. Okay, so MgCl2. Okay, and then we've got for balancing here, 2 and 2, 1 and 1. So it's already balanced. What kind of reaction is it? Synthesis, yep. All right, number 2 you've already seen before. What's dihydrogen monoxide? Water. Yeah. Okay, gives off, that means it's not reacting with anything, hydrogen and oxygen. Okay, what kind of reaction are we looking at there? Decomposition. Okay, and we already saw this reaction. We saw it on the last slide, and it was our example of a decomposition reaction in our notes. Okay, so it's like the 3rd time we've seen this one. All right, when I want to balance this, my hydrogens are already balanced as a 2. Oxygen is also a 2, which is the biggest number, but it's only a 1 over here. So what needs to go in front of water? 2. Which gives me how many hydrogens? 4, so what needs to go here? 2. Right. Okay. How many people are done the 3rd one? Okay, let's have a look at the 3rd one. So we have aluminum, so Al, and oxygen. What do I have to remember about oxygen? It's a special element, yeah. To produce aluminum oxide, which is an ionic compound. So this is a -2, aluminum is a +3. So we're going to have Al2O3. All right. If I want to balance, sorry, what kind of reaction is that? Yeah, it's a synthesis reaction. Okay, if I want to balance it, start with my biggest number, which is 3.
Could we please have the grade 12 with the surname starting from A to G? Go down to the cafeteria for your pictures.
Okay, what's the lowest common multiple of 2 and 3? 6. Okay, so if I multiply this side by 2, 2 times 3 is 6. If I multiply this side by 3, 3 doesn't have that many bumps in it. 3. Okay, 3 times 2 is 6. But now I also have to look at my aluminums. This 2 also applies to aluminum, so how many aluminums are there? 4. What needs to go here? Right. Okay, making sense? All right, how many people are done 4 and 5? Okay, I'm going to give you a few more minutes. If you're done 4 and 5, try 6 and 7. Okay, and see how we do on those. Okay, let's have a look at 4 and 5 here. So what do we have to remember about phosphorus for number 4? That it's special, but it's more special. It's a 4, right? Okay, and oxygen is obviously the regular kind of special, 2. Okay, and that is going to produce phosphorus pentaoxide, so PO5. Okay, so we're supposed to start with the biggest number, right, which is 5. And if I start with that, that's fine, but I'm going to run into a problem. Okay, what's the lowest common multiple of 2 and 5? 10. So that means I have to put a 2 here to balance that, right? Is that going to give me enough phosphorus? No. All right, so that didn't work. And it doesn't all the time. Okay, it works most of the time to start with the biggest number, but it doesn't work here. So then I'll go down to the next biggest number, which is 4. And it happens to be on phosphorus, so I'm going to balance the troublesome element first. Okay, phosphorus was the one that made that not work anyway. So if I put a 4 here, okay, that now balances my phosphorus and gives me how many oxygens? 20. Okay, what needs to go in front of this? Right. Okay, everyone all right with that? Yeah. So like I say, it doesn't work every single time to start with the biggest number, but it works often enough that when it doesn't, it's pretty obvious what to do. Okay. All right, let's look at number 5 here. Nitrogen trihydride, NH3. Common name for that is ammonia. Okay? It's the stuff that smells like glass cleaner. It's what's in glass cleaner, actually. And that's that smell if you've ever used Windex. Okay? That's the smell of ammonia. And it reacts with oxygen, O2. Okay? And it's going to produce nitrogen. What do I have to remember about nitrogen? It's special, yep. Okay? And dihydrogen monoxide, water. Okay? All right, so guys, on a question like this where I'm asking you to write it out in formula form, balance and identify the type, which we forgot to do here. Okay? There's no type on this one. Okay? We haven't gone over any reactions of that type. It's not a replacement reaction because NH3 is a molecular compound. Okay? So this is kind of beyond what we look at. There are other reaction types beyond the 5 we look at. Okay? So what I would be looking for in terms of marks here would be that you have the reactants correct, you have the products correct, you have the reaction type correct, and you have it balanced correctly. Now, this can go south in a hurry because if you miss one drop and swap or one special element, you're not going to get the balancing right either, are you? Okay, so you can go from getting 4 out of 4 to 2 out of 4 pretty fast, okay, if you miss one little thing, right? Because if you miss one of the little numbers, you're not going to get the balancing mark either. Okay, so you really have to make sure you know those drops and swaps, you know your special elements when you're writing out reactions. All right, for balancing on this one, biggest number is 3, okay? But here's going to be a problem with that. If I balance it first, it's going to be another one like this that's not going to work well. Okay? I have 3 here and I have 2 there. Lowest common multiple is 6, right? All right. If I put a 3 in front of this to make 6, is that going to work for my oxygens? It's not. Okay. So what I'm going to want to do instead, okay, is I am going to want to try and double what I was going to do originally.
Could the grade 12 students with the surname starting from H to L head down to the cafeteria for your picture?
Okay, so actually let's just walk through what that would look like if I did all of that. So I'd have a 2 in front of this, my nitrogens would work, okay, but as soon as I get to here, okay, I gotta have a 1.5 and I can't have that. Okay, we ran into that same problem with the combustion reactions. How did we solve it in a combustion reaction? We'd start it with a 2. In other words, we double how much of everything there was. If I double how much of everything there is, will that take care of my 0.5 problem? Yep. So anytime you run into that, and it's almost always with oxygen that you run into that, including the combustion reactions, take your first number away and double it. That'll get rid of your 0.5 problem that you encountered. Okay, so now I have 4 nitrogens, so I put a 2 there. I now have 12 hydrogens, so I put a 6 there. That gives me 6 oxygens, I put a 3 there, and that's the lowest balancing numbers I can have for that reaction. That's a fairly tricky balance, that. Okay, because none of the rules work, right? We started with the biggest number, that didn't work. Okay, we had to double everything in order to make it work. Okay, number 6 is probably the easiest one you could ever run into. Carbon plus oxygen gives carbon dioxide. Done. Okay, is it already balanced? Okay, that one it didn't really get much easier than that. Okay, let's have you try number 7 and number 8. Actually, I want you to try the rest of those last 3. Okay, we'll walk through those, and then we're going to have a look at predicting, which is like no harder than this is. All right, so for this one here, we got calcium oxide, which is an ionic compound, so we got a drop and swap. That's a -2, that's a +2, so that one works. Okay, plus magnesium chloride, Mg, with Cl, also ionic compound. That's a -1. This is a +2, so when we drop and swap, we get MgCl2. Okay, and that is going to produce magnesium oxide. This is a -2, this is a +2, so that compound is okay. And then CaCl, this is a -1, this is a +2, so we should have CaCl2.
With the following grade 12 students with the last name starting with M and going to S. Make their way to the cafeteria for your picture.
All right, what kind of reaction am I looking at there? That's a double replacement reaction. All ionic compounds, okay, all we're doing is switching the metals. So now if I need to balance that, how does it look for balancing? Okay, well, how many calcium here? How many calcium over here? 1. How many chlorine here? How many here? 1 magnesium, 1 oxygen. I think it's good. Okay? Sometimes you get lucky and it's already balanced. Okay? All right, for hydrogen iodide, HI, it's an ionic compound. That's a -1, that's a +1, so that one's good. And it reacts with oxygen, special element, okay, to produce iodine, special element, and water. Okay, iodine is one people forget is special all the time. Okay, so don't forget. And if we're looking to balance this thing, oxygen's a 2 on this side. Now it's a 2 on that side, but now there are 4 hydrogens. So I gotta back up and make 4 hydrogens. Now there are 4 iodines. Back over here, now there are 4 iodines, and now everything is balanced. Okay, and what kind of reaction is that? Single replacement, yep. Okay, we got ionic compound and an element reacting. All right, and then our last one here, we got magnesium and nitrogen, special, okay, producing magnesium nitride, Mg with N. Now, is that an ionic compound? Yep. This is a -3, this is a +2, so we're gonna have Mg3, N2, right? The N's are already balanced, just need a 3 here to make my magnesium work. Okay, what kind of reaction is that? Synthesis. All right, questions on those? Okay. Now, we're not going to do any of these today, but we might do some of them on Monday. They're just balancing and they're fill in the blank. If it's already balanced on a fill in the blank question, what do you put in all the blanks? Right? Okay. Can you identify the types of these reactions, even though you don't know what the products are? Definitely. None of the 5 reaction types that we've gone over start the same. Okay? So if I'm looking at the first reaction there, it starts with 2 elements reacting. What's the only reaction type that we have that's 2 elements reacting? Okay. What happens in the synthesis reaction? They go together, right? The 2 elements combine to form a single compound. So the only thing you really have to know well to do prediction is know the patterns. Okay? In a synthesis reaction, the 2 elements join together to form a single compound. All right, what would a single compound between these 2 things look like? Well, it would have magnesium and iodine. This is a -1 and this is a +2, so I would have to drop and swap it. But that would be my product then. Okay, is the reaction already balanced? Okay, was that very hard?
No.
Not really. Okay, it isn't any harder than what we're already doing. Right? You just have to know the patterns. Okay. Try number 2. Identify the type and use that reaction type's pattern to predict the products. Okay, what kind of reaction is number 2? I have an element reacting with an ionic compound. Right, single replacement. Okay, in a single replacement reaction, we have element, be it metal or non-metal, in this case a non-metal, reacting with an ionic compound. Now, the rule for a single replacement reaction is that that lone element is going to replace the part of the ionic compound that it's like. since chlorine is a nonmetal, it's going to swap out what part? Yeah, it's going to swap out the fluorine because fluorine is the nonmetal. That means fluorine is going to wind up by itself, and sodium and chlorine are going to wind up together. Chlorine has replaced fluorine. Now, everyone follow me so far? Okay. Single replacement reactions have the most to remember. Okay? Because I just produced an element. Is it special?
Could all the remaining grade 12 students head to the cafeteria for your picture?
Okay. Fluorine is one of our special elements. Okay? It comes as a 2. All right, so I got to remember that. And I made an ionic compound which needs to be dropped and swapped. Well, this one actually doesn't because they're both 1s, okay? And it works out the way it's supposed to. So now what do I need to do? I got to balance it, yeah. My reaction isn't balanced yet. On this side, there are 2 chlorines. On this side, there's only 1. So what needs to go here? That gives me 2 sodium. Now I got 2 sodium here. Okay, and that gives me 2 fluorine, which is good because there's 2 fluorine on the other side, and now it's balanced. Okay. So when you're predicting the products of a reaction, and this is what we're going to look at on Monday, okay, you have to know the reaction patterns. Okay, so you've got to know your 5 types well enough to be able to go, oh, I see what kind that is, and I know what's going to happen. Okay, so for number 3 is pretty straightforward. What kind of reaction are we looking at in number 3? It's a combustion reaction. Okay? What are always the products of a combustion reaction? Carbon dioxide and water. Right? Okay? So that just comes from me knowing that pattern. Okay? If I know the pattern of a combustion reaction, I know what the products are. Right? For balancing this one, combustion reactions have special rules. Okay? Alphabetical first, and do I need the rule of 2 for this one? I do, because 2 is an even number. All right. 2 times 2 is? 4. Okay, 2 times 6 is? 12. Okay, so now what do I do with the oxygens? Okay, 4 times 2 is how many? 8 plus 6 more is 14. What times 2 will give me 14? Okay. It's easy to forget. There's oxygens in both places on that product side. All right. So on Monday, we're going to look over the rules for predicting, do some predicting, and our pre-lab activities for our reactions lab, which we'll be doing on Tuesday. Okay. So that is the plan going forward. What's due Monday morning at 8:30? Make sure you have it submitted before 8:30 Monday morning, please and thank you. Okay?